For 8, it says use long division to determine if 2x minus 1 is a factor of the polynomials below. Show your work and explain your answer in words. So is 2x minus 1 a factor? Yes or no? And the big thing is I'm just supposed to use long division, right? So I divide 2x minus 1 into 6x to the third plus 7x squared minus 9x plus 2. So I'm going to use this long division. 2x goes into 6x to the third. You divide, that gives you 3x squared, right? Divide this by this, that gives you 3x squared. 3x squared times 2x is 6x to the third. 3x squared times negative 1 is negative 3x squared. So remember, first step, divide this by this to get that. Next step, distribute this to the whole thing to get this. Next step, subtract down. So these cancel. And 7 minus negative 3 is positive 10x squared. And then next step, bring this down. And then we just repeat. 10x squared divided by 2x is 5x. We put a plus there between. Now distribute this times all of this. That's 10x squared minus 5x. Now subtract down. These cancel. Negative 9x minus negative 5x is negative 4x, because remember, subtracting a negative is like adding a positive. So negative 4x and then plus 2. And now negative 4x divided by positive 2x is negative 2. So so now take this times this and distribute. Negative 2 times 2x is negative 4x. Negative 2 times negative 1 is plus 2. Subtract down. These cancel, so I have a remainder of 0. So my remainder is 0, and this is really the big thing. If my remainder is 0, is this a factor? Yes, absolutely. So how did long division help me determine my answer? What I write is, when I divide using long division and my remainder is 0, then I know I have a factor. So try this one now, where you're going to be trying 2x minus 1 into here, and see if it divides evenly. And if it has a remainder of 0, you have a factor. If you have a remainder that's anything other than 0, you answer no. Same thing right here, using long division to determine if x plus 5 is a factor. So you tried to divide x plus 5 in here and x plus 5 in here, right? And remember, there's a way to use graphing to check this, right? I could set this factor equal to 0, 2x minus 1 equals 0. I could add 1 to both sides, divide by 2, x equals 1/2, right? And if I graph this and it has a 0 at 1/2, then I know I've found a factor, right? Because if this is a factor, then it should have a 0 at 1/2. So it's really good to be able to have multiple strategies because you can check your work. So I'm going to do that right now. 6x to the third plus 7x squared minus 9x plus 2. So I'm going to graph this, and I'm looking for it to cross the x-axis at positive 1/2, or to touch the x-axis at positive 1/2. Now, if you look here, it looks like it kind of does, but it's hard to say if that's exact. You can trace and see, and it looks like, yeah, notice that you're getting close to y equals 0, and you're getting close to x equals 0.5, which is the same thing as 1/2. But again, it's not perfect. So I might like to check the table and see what's happening with my zeros. So I don't know. I want to find a place where y equals 0 at positive 1/2. And you can't, you're going by ones right here. So remember, you can change your table set and change the table, change in table to 0.5. Then your table will go by 0.5s. So negative 1, 0.5, 0, 0.5, and look what happened here. At 0.5, my graph came to a 0. So now I can feel pretty sure. Now I know for sure, like my graph confirms it, that 2x minus 1 is a factor and 1/2 is a 0. So you can do these by long division and then check with graphing.